We are almost there with the power supply for the Data General Nova. Yes, the power supply from scratch. This is it. I've mounted it in here, at least temporarily, but you know, it could become quasi-permanent because it's fairly stable, and we'll see how it performs. And but let's just go through this. A lot has changed since the last video because I consolidated a lot of things. Right here we have the modern ATX power supply. This is providing plus 5 volts, negative 5 volts, and plus 12 volts, which I'm choosing to use for the lamps. This is just a breakout board that I got on eBay. I think I ordered it from one of those Chinese vendors. I like these. They're very convenient, very concise, and so I hooked, let's see here, I hooked all 4 ground connectors to the ground right here. The 5 volt, both of those to the 5 volt right here. And then the more interesting stuff, esoteric stuff on the back side here. Uh-oh. Oh no, it's coming apart already. This is a problem. This is a problem. I better fix that right now. Right in front of you. I'm going to fix it. Might as well. I did not get that tight enough. So this is more ground, and this ground goes to the power supplies that are going to turn, that are going to make the 15 volts. All right, open that connector up there. Push that in, nice and sturdy. And for this one, we'll tighten this down. Okay, I want to get it a little bit tighter than that, so I'm going to use a flathead screwdriver that I've customized for these things. Okay, there we go. 2 wires on the ground on this side. Okay, now they go to the 15 volt connectors, which we'll get to in a minute. And so let's see, what else do we have here? Here we have the plus lamp and lamp ground right there. Plus V lamp, and is that what it says? Lamp ground? Yep, lamp ground on these 2 wires right here, and I have them going right to that. And so that is plus 12 volts, this one connector right here, and then the other one into the same common ground. And then there's one left, and that is the negative 5 unregulated. Well, I'm thinking it's probably going to be, you know, more regulated than they planned on, just because it's a modern ATX power supply. But we have that connector right over here, negative 5 volts, and there's only one connector there for the negative 5 and the negative 12. And all of this is just a breakout board from, you know, this plug, which in the original design, when this was in a computer, it just plugged right into the motherboard. And this is a fairly standard plug size. I think this breakout board is designed to handle multiple different configurations of this, which is why it's a little bit larger. But it only fits in one way, and it seems to work very well. I've used this for other computers that I've replaced the power supply in, and just, you know, hooked up a modern ATX power supply outside of the chassis. In particular, the AT&T Unix PC. All right, so let's put this back in position here. There we go. Now, what else do we have here? All right, so let me move this again. Here are the laptop power supplies. So we have the plus 15 volts, the other plus 15 volts. I think this is the original Toshiba 5 amp. This is the generic, which I think is only rated 4 amps. But I have those together in parallel. So I suppose you add that together, it's 9 amps, which is right about what I believe the specifications are calling for. And then we have the negative 15 volts. Now, as I said in the previous video, this is a Dell laptop, and it's actually at 19. It operates at 19.5 volts. But again, I'm using the NTE 968. voltage regulator, which is should be a 15-volt voltage regulator. And I have that mounted right here, and what I've chosen to use for the heat sink is I've mounted it to another power supply chassis, another modern ATX power supply chassis. Now, it might be hard to see, but what I've done here is this. Uh-oh, messing up the bench here. Okay, might be hard to see, but what I've done here is this looks like it's also another modern ATX power supply. Well, it used to be, except the electronics in it went bad. I decided it was more trouble to fix, and so I gutted it. So basically, this was an empty chassis with just, you know, the 110 volt or the power in, right? The AC power in. And so I don't want to show you in there because it's just a mess. But basically, I use this for some mass power routing. So I've connected these three 110 volt plugs into here, as well as coiled up some of the excess wire from these power supplies as well. And as a last thing, I think I can't get that out with the way I have it in here, but I just used one of the screws. Let's see if I can show that. Yeah, there we go. I just used one of the screws for the hold the cover on, and I just used that as the heat sink. So we'll see if that does well enough. This should be fairly low load because the negative 15 volts wasn't really supposed to do much, and I may only use it for the 60 cycle oscillation if that'll be necessary, but there's still a whole lot of questions that I don't have answered about that. So that's why I decided that the 60 cycle, that might be one of the last things that I work with, because I'm going to really want to understand what that's going to be used for. So there we go. It fits in there fairly nicely. I've just used some we'll call them wire ties, right? Zip ties to hold this stuff together, and some double-sided tape, which is not sticking at the moment, but you know, it's tacking it in place so it's not flopping all over too much. And maybe I'll glue this or something if I really like the position, but it seems to be all hanging out fairly well. And some of the unused cables from the ATX power supply, you might notice those here. I've just tied those up and out of the way. So it's fairly neat. And I've plugged it in, and I don't see any sparks, and nothing seems to be shorting out yet. I've just plugged this in. I have not yet plugged this into the backplane. When I do, it's going to be an empty backplane. But still, and I don't have the front face on. I don't have the front console on, so I won't be burning out any bulbs. I just want to be carefully, methodically checking my voltages all the way throughout once I do this. So I think we might be ready. This is what I did with the resistor capacitor board for the RINH, and I'm pretty happy with it mounted to cardboard like this because it keeps the backside from touching the chassis, and it fits in there, fits in the connector nice and fairly nicely. Let's have a look at that. I cleared up this area so that we could see how that connects in there. See that right there? It just connects to that card edge female connector there on the back plane. And this is the lower one. This is the upper one in the event that there was an upper power supply to power the upper boards, but we're not going to get there just yet, so don't want to get too ambitious. But if this works, we'll use the same method for the upper power supply, should that be necessary. All right, so where was I? I did not plug that in right. One of the things I wanted to point out is in this slot here, while I'm thinking about it, there's this card edge female connector. There's a slot, a separator. You can't see it because it's right under there. There's a separator here, and this juts out quite a bit, and I wasn't able to cut the slot into this board far enough. So I've put on some marker, some Sharpie right there as I cut into this, because I think at some point I'm going to redo this board. I may have it, you know, professionally designed and printed, or manufactured at a PCB house on another version of this, if this works out well. And I'm going to want to make certain that this slot goes deeper, because right now, if we look at these, let me take this off and see if we could, you know, can see this well. If we look at the marks that this connector has made in the slot, in the socket, as I've taken it in and out. We don't have much engagement, right? I believe the word for this is purchase, not purchase something monetarily, but how far in the connector it goes, how far in the socket you can push something. It's not really going in that far, and that's because it's hitting this. So I think this needs to be a little bit deeper, but hopefully it's going to be good enough for the test and good enough connections there. Again, some review. From here to here, that's going to be 5 volts on this side. So that's from 1 to 5. From 6 to, gosh, what is that? From 6 to 21, here it is again. From 6 to 21, we have the RINH, which I guess is the core memory inhibit, and those are the ones that are connected to all of these resistors that I showed yesterday, or I showed in the previous video, and the capacitors according to the schematic that we showed yesterday right here. Okay, and all of that should be connected properly. So, and then we have 15 volts going in here, right, in the larger one, and the smaller one is ground for the capacitors to be grounded. So there we go. I've made my own resistor board. All is happy. And then from 22 to 26 on this side is all the interesting stuff. And so I'm not going to go into that in detail right now, other than to say that it's the 23 to 26, there's your lamp ground, 60 cycle memory okay, power fail, right? I have those not hooked up to anything yet because I want to do testing, so I have these draped over the side of the chassis. Let's flip over real quick just to give a review. You can't see much because I've covered this over, but again, 25, these first 5 should be 5 volts here. All of this in the middle should be ground, right? And that should be 32 to 47 should be ground. And then after that, we have 15 volts, which I should have connected to both of these, as well as the resistor board, right? That both of these in parallel are connecting to 15 volts here, as well as the 15 volts that goes to, I think it's this one right here. Pretty sure. I have that connected on the other side of the board, but that should be this one right there. That's the 15 volts. And then the rest of them, 49 through 52, negative 15, available as a customer option. I did hook it up because I went through the trouble of making it, right? And plus 5 volts okay, negative 5 volts on reg, and plus 5 volts on reg lamp. So what we have is the plus 5 volts okay. Again, I have that just out of the chassis so we can do some experiments with it. But negative 5 unregulated, well, I have that connected right here. Is it right there? I think it is. Yep, negative 5 volts right there. Okay. And then the 12 volt for the lamp, I have those connected right here, 12 volt and ground. So it says 15 volts unregulated for the lamp. The sources show anywhere from 11 to 17 volts, so I figure I'm pretty good with 12. Hopefully I don't burn out any bulbs. Maybe that's my biggest danger. But at only 12 volts, I hope not. And then the lamp ground right here. So I think I have all of this correct. So let's see. We are 13 minutes in. So here's what I'm going to do. I am going to plug this in right here. Let's see. Let's go a little bit wider view. I don't have a lot of room here. We're going to plug this into the back plane. Just want you to see that, how that goes in right there. Plugging that into the back plane right there, just like that. Okay, that's about as far as it'll go. You see that's hitting right there. But I can't cut it in anymore, otherwise I'll break one of these connectors on the other side of the board. So hopefully that'll be good enough. Now, get these small wires out here, because we're not going to be hooking up any CPUs this video. I'm not going to get quite that aggressive. I made a custom cable, a custom power cord for this thing, and now I can't find it. What did I do with it? Oh boy. Can't find it. Where is it? Because I'm going to plug this thing in and we're going to check some voltages.